concepts of geometry in lesson 7. We're looking at midpoint and distance. We've already talked a little bit about midpoint so far this unit, but we'll be looking further at that, and then of course distance. Um, One of the big things that comes up in this lesson is the formulas, and so one of the big questions here is, how is the distance formula derived? Where does it come from? Learning target number 10 and 11 are the two things you're going to need to know for the test from this section. Number 10, calculate the midpoint between two coordinates, then calculate the distance between two coordinates. And ultimately it comes down to, you're going to have to use the formulas. Um, so, all right, let's take a look. Some vocabulary. So the midpoint and distance are both here, and they're both in two forms. You've got on a number line, and then on the CCG, the Cartesian coordinate grid, which is probably where you're going to spend most of your time, but it's important to know how to do this on just a number line as well. So the midpoint on a number line is basically, I want you to think of this as like the average. And so if you had, for instance, we'll just draw a quick little number line here. So let's start, here's 0, we'll say here's -1, 1, 2, maybe 3's over here. If I wanted to find the midpoint between 1 and 3, okay, well I just want to show you this example so you can see how it works. But if we just go ahead and take 3 plus -1, remember average is you just add up all your numbers and divide by the number of numbers. Well, here we're adding up our two numbers. We have 2 of them, so we divide by 2, and we wind up with 3 plus -1 is like 3 minus 1, which is 2, divided by 2, which is 1. And sure enough, you can see 1 is right here in between -1 and 3. So in general, we're just going to say A plus B divided by 2 is how you're going to get the midpoint. But that's on the Cartesian coordinate grid, on the number line. On the Cartesian coordinate grid, your formula looks like this. It's still the average, but on the Cartesian coordinate grid, remember we're looking at an x and a y value. So this is the first time this year that we've looked at the Cartesian coordinate grid. So you need to not only find the average of your x, your horizontal distance, but also the y. So just to designate, because we have two coordinates, we'll say x2 plus x sub 1 divided by 2. So that'll give us the average of our x, just like we got the average of our x up here. But then we also want the average of our y. So y sub 2 plus y sub 1 divided by 2, and that is going to give us the average of both the x and the y. So I guess just the key thing here is, you've got these two coordinates that you're finding the midpoint of. Okay, so this coordinate over here just be x1, y1, and this one down here would be x2, y2. Okay, so you take the x values, average them out. Then you take your y values and average those out. All right, and you'll see some examples of that here pretty soon. The next one is distance. So for distance, you're going to take the absolute value, because remember, distance is always got to be positive. You can't have a negative distance. And so you're going to take the absolute value of the difference. If we just took a quick little look at a number line again. So here again, we'll say this is 0, got -1, 1, 2, and 3. If I want to find the distance between, say, -1 and 3, okay, well, I could say 3 minus -1, and that would give me 4, and the absolute value of 4 is 4. But the distance between 3 and -1 should be the same as the distance from -1 to 3, and so I could turn it around. I could say negative, so we'll say or, -1 minus 3, but since we're taking the absolute value, we get absolute value of -4, which is still just 4. So both of them are 4. All right. Sorry, I meant to say this one was distance. Okay. So the distance on the Cartesian coordinate grid basically comes from a souped up version of the Pythagorean theorem. So the distance formula is going to go like this. You've got a big square root, and then it's y2 minus y1 squared plus x2 minus x1. Oops, ran out of space. Squared. Okay. So I'm just going to head up here to show you. All right. Well, if I just make a very small grid here, 5 by 5. Okay, so we've got a point here at 1, 5. And we'll put another point here at 3, 2. If I want to find the distance between these 2 points, okay, well, I hope that it makes sense to you that I could just kind of make some horizontal and vertical lines like this. And then this distance right here would just be the horizontal distance. And that would be the, well, just like on a number line, this I would take the absolute value of the difference. And so, here, down here, you're subtracting to get the horizontal distance, x2 minus x1. And so over here, x2 minus x1 would be 3 minus 1, or 2. And it would be the same thing as just counting over 1, 2. And then if I went up 1, 2, 3, that would be the same thing as saying y2 minus y1. It would be 5 minus 2 is 3. And so when we have a right triangle, well, this is the Pythagorean theorem, something you guys have done a number of times in previous classes. We would say 2 squared plus 3 squared equals the hypotenuse squared, but the hypotenuse in this case is the distance. And so this is all this comes from. This is x2 minus x1 squared, of course. Okay. And then this 3 squared, all that was y2 minus y1. And then, of course, squared, because we're in the Pythagorean theorem. And then equals c squared, but c is just the distance. And you should remember from algebra that when we, how do we get rid of something squared? Well, we take the square root. So if I take the square root of the right side, I got to take the square root of the left. And so I take the square root of this whole thing, and sure enough, I've got my distance formula. So that's where the distance formula comes from. It comes from the Pythagorean theorem. All right, just a few quick examples. The midpoint of LM is A, which is at 2, -1. So here's 2, -1. And we'll call this M. Sorry, the midpoint of LM is at 2, -1. So this is the midpoint. One of the endpoints is at -3, -5. So, all right, here's L. What are the coordinates of the other endpoint? Well, so we're going to have to use a little bit of algebra here. This is the midpoint, and it is at 2, -1. So if I started out with my midpoint formula, I would know that -3 plus x sub 2 divided by 2 would have to get me this midpoint value for x, which is 2. And so I could just use a little algebra to solve here. I'm going to multiply both sides by 2 to get rid of that. So now I have negative 3 plus x sub 2 is equal to 4. And then I add 3 to both sides, and I get x sub 2, the x value of my other coordinate on the other end, is going to equal 7. I'm going to do the same thing now with my y. So if the original first point I've got is negative 5, I'm going to say negative 5 plus y sub 2, which is negative 1. Oops, sorry. It's y sub 2 divided by 2 is equal to negative 1. Then we're going to multiply both sides by 2. Now I've got negative 5 plus y sub 2 equals negative 2. I add 5 to both sides, and I've got y sub 2 equals positive 3. And so now I've got the x and the y coordinate for my new spot, and that's going to be at 7, 3. And hopefully we can take a look over here, and that will work out, and it'll even look like it's supposed to. So 7, positive 3. Sure enough, I draw my point here, M, and not only is it equidistant, but it's all on the same line over there. Okay, so that's one application of midpoint. Let's take a look at one for distance. So you're on a zip line course and you're traveling through the jungle. How far is it from the start to the tree? So we've got the starting point here, and it looks like this is at negative 40, negative 30. And then the large tree here is at 30, positive 10. Okay, so we have an x1, y1, x1, y1. And over here we have an x2, y2. And we're simply, we could think of it as an example of the Pythagorean theorem, okay? Or we could just skip kind of straight to that distance formula. So we'll say the distance here is going to be the square root. And so we'll say y2 minus y1, so 10 minus negative 30. Make sure that you put those negative signs in. That's one of the real common errors, is because there's already a negative sign there, students will forget if I have a negative sign. Plus, a lot of students sometimes will accidentally make that a negative sign or a minus sign, but don't make that mistake. If you remember that this is the Pythagorean theorem, you'll get a squared plus b squared. You'll remember that that sign there is positive. And then for my x's, I've got 30 minus negative 40 squared. All right, at this point, my next step, and you do need to show your steps here, I'm going to take care of the stuff on the inside of the parentheses using good old PEMDAS. So 10 plus 30 would be 40. So I've got 40 squared plus 30 plus 40 is going to be 70 squared. Let's see. All right, we're getting into some bigger numbers here, but 40 squared, 4 squared would be 16, so this is going to be 1600. And then 70 squared is, well, 7 squared would be 49, so this is going to be 4900. And as I keep going down, we'll add these two things together. And yeah, don't make sure that you don't accidentally just take the square root and cancel out these squares. That's another common mistake, and make it something like 110. That's violating all sorts of algebra rules you cannot violate. I think when you add these two together, you should get 6,500. And so just kind of the rule of thumb here, I don't have a calculator with me. We could estimate, but if you have a real-life question, then I would like for you to have a real-life decimal answer. And so I would expect you on a test to go ahead and use your calculator, turn that into a decimal. But if you have a pure math problem with no context to it, just leave it in the exact square root form. All right, well, that's it for lesson number 7.